We will now discuss three questions from linear algebra, and these three questions were asked in the Telangana State Set exam held in March 2023. These questions are suitable for the aspirants of JL, DL, AP Set and CSIR NET examinations also. This is the question number 61 with this question ID in the TS Set 2023 March examination, and the question is from the linear algebra. The given question is the dimension of the vector subspace W is equal to the set of all 2 by 2 matrices A, B, C, D, where B is equal to C and the trace of A is equal to 0 of M2 over C, the set of complex numbers, is. We are given 4 options. Right. So we are given a vector space M2, the set of all 2 by 2 matrices with complex entries over the complex field C. And we are also given a subspace W of M2C given by W is the 2 by 2 matrix A, B, C, D, where B is equal to C and the trace of A is equal to 0. And that is equal to, replace C by B, and trace of A is A plus D, that is equal to 0, means D is equal to minus A, and replace D by minus A. So then you will get the set of all matrices A, B, B minus A, where A, B belongs to the field of complex numbers. Agreed. This can be written as a linear combination of A times 1, 0, 0 minus 1 plus B times 0, 1, 1, 0, where AB belongs to C. This is the linear span of these two matrices 1, 0, 0 minus 1, 0, 1, 1, 0, and they are linearly independent. Therefore, this is the basis for W. Therefore, the dimension of W is equal to the number of elements present in the dimension in the basis, and in the basis there are 2 elements. Therefore, the dimension of W is equal to 2. Let's look at our options, and our answer 2 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem. Let's move to the next question. This is question number 63 with this question ID from the TS Set 2023 March examination and from linear algebra. The given question is, let A belongs to M4 over R, that is the set of the vector space of all 4 by 4 matrices with real entries, and this A belongs to M4R be an invertible matrix, that means its inverse exists, then which of the following statements is not true? We are given 4 options. Option 1, rank of A is 4. Option 2, 0 is an eigenvalue of A. Option 3, dimension of the null space of A is equal to 0. Option 4, for every B belongs to R to the power of 4, the system of equations Ax is equal to B has a unique solution. Agreed. Let's now discuss the solution of this problem in detail. And by looking at these options, for me, the option 2 is not true. How? It is known that A is singular if and only if 0 is an eigenvalue of A. This is the theorem what we know. We are given A belongs to M4 over R, and we are also given A is invertible. A is invertible means A inverse exists, that is A is non-singular. And when A is non-singular, 0 is not an eigenvalue of A. Why? A is singular if and only if 0 is an eigenvalue of A. From that, A is non-singular, then 0 is not an eigenvalue of A, you will obtain. So, 0 is not an eigenvalue, but whereas in option 2, 0 is an eigenvalue of A is given, therefore, option 2 is not true, and the question is over. And the answer to this question is option 2. Right. The answer is over. But some of our students will ask, Sir, why don't you prove the remaining 3 options? Yes, I will do that. So I will now prove the remaining 4 options are true. That's our given question, and we are given A belongs to M4 over R, A is invertible, means A is non-singular, means determinant of A not equal to 0. When, and take the option 1. When determinant of A not equal to 0, then what will be its rank? The rank of A is 4. Therefore, option 1 is true. Agreed. And we have already seen the option 2 is not true. So option 2, determinant of A not equal to 0 implies 0 is not an eigenvalue of A, where you are using this result A is singular if and only if 0 is an eigenvalue of A. Therefore, the option 2 is not true. Option 3. So option 3 is the dimension of null space of A is equal to 0. We have to. What is null space? What is the null space? Dimension of null space? The nullity. Nullity. How do I get nullity? And when I know rank, that nullity will come from a theorem called rank nullity theorem. By rank nullity theorem, the rank of the matrix A plus the nullity of the matrix A is equal to 4. Where we know the rank of A is 4, therefore the nullity of A is 0. What do you mean by nullity of A? It is the dimension of the null space of A is equal to 0. And hence the option 3 is true. Right. Now option 4, Ax is equal to B. We are given A is invertible, means its inverse exists. Therefore, pre-multiply both sides by A inverse. So you take Ax is equal to B, pre-multiply both sides by A inverse, then you will get x is equal to A inverse B, and that is the unique solution, because A inverse is uniquely determined for invertible matrices. So the option 4 is also true. So the option 4 is true. We are asked to find that statement which is not true, and the statement which is not true is the option 2. The answer to this question is option 2. That is the detailed discussion of the given question, and it is also an easy question. Now let's move to the last question, the third question, question number 65 with this question ID. It is from TS Set 2023 March examination and from the linear algebra. Now the given question is a linear operator T on a complex vector space V has characteristic polynomial x minus 2 whole cube into x minus 8 whole square and minimal polynomial x minus 2 whole square multiplied by x minus 8. Then which of the following is not true? The 4 options given here. Option 1, dimension of V is 5. Option 2, Jordan form is uniquely determined by this given information, that is, the information is regarding characteristic polynomial and minimal polynomial. These two is the given information. Option 3, there are exactly 2 Jordan blocks in the Jordan decomposition of T. Option 4, the eigenvalues of T are 0, 2 and 8. So let's now discuss the solution of the problem in detail. We have the linear operator T from the vector space V over the complex field to itself. We are given x minus 2 whole cube into x minus 8 whole square is its characteristic polynomial. Let's now discuss the options one after the other in the next slide. Right. Let us take the first option 4. The eigenvalues of T are 0, 2 and 8. We know the characteristic polynomial, therefore its characteristic equation is x minus 2 whole cube into x minus 8 whole square is equal to 0. What are the eigenvalues? The eigenvalues are 2 and 8. But whereas in our option it is given the eigenvalues of T are 0, 2 and 8. But the eigenvalues of T are 2 and 8 only. Therefore, the option 4 is not true, and many students will stop here and they will say, my question is over. My question is over. Let's look at the remaining story. Now let's get into option 1. The dimension of V is equal to 5. How do I show? The dimension of V over the complex field is equal to the degree of the characteristic polynomial. What is the degree of the characteristic polynomial? 3 plus 2, that is 5. Thus, the dimension of V is 5. This is true. Therefore, option 1 is true. Let's move to the next option. That is option number 2. Jordan form is uniquely determined by the given information. What is the given information to us? One is the characteristic polynomial, that is x minus 2 whole cube into x minus 8 whole square. The other is the minimal polynomial, that is x minus 2 whole square into x minus 8. These two will determine a Jordan form in this case. So how the Jordan form will look like? J is equal to 2 x minus 2 whole cube. So along the main diagonal 3 2's will be there. X minus 8 whole square. Along the main diagonal 2 8's will be there. But this minimal polynomial will tell you x minus 2 whole square will tell you that the eigenvalue 2 repeated 2 times from the minimal polynomial will give you that there is a Jordan block of order 2. And whenever the Jordan block of order 2 comes, there will be this 1 coming into the picture. So that is the Jordan block of order 2. And the x minus 8 will give you Jordan block of 8. And x minus 2 whole cube will tell you 2 should appear 3 times. What about the remaining 2? That will be the Jordan block of 1. And 8, Jordan block of 1, Jordan block of 1. So that is the Jordan form of the given linear transformation with this characteristic polynomial and minimal polynomial. Right. And it is uniquely determined by its characteristic polynomial and the minimal polynomial. Thus, our option 2 is also true. Now, let's get into the option 3. There are exactly 2 Jordan blocks in the Jordan decomposition of T. But how many Jordan blocks are there? There are 4 Jordan blocks are there. But it is given here is exactly 2 Jordan blocks. That means this option 3 is also not true. So notice that the Jordan decomposition of T has 4 Jordan blocks. So the option 3 is not true. So that's right. The option 3 is not true. So we have to find out those options which are not true, and we have seen option 4 is not true. Now option 3 is not true. Therefore, the answer to this question is option 4 and 3. But unfortunately, we got 2 options which are not true, and it is a multiple choice question. You are expected to have only one correct answer. But to make only one of them is to be correct answer, either we have to modify option 4 or option 3, so that only one answer will come. To do that one, I suggest that we modify the option 4 as option 4. Now we will give it as the eigenvalues of t are 2 and 8. The actual option 4 was the eigenvalues of t are 0 to 8. But now that is modified to 2 and 8 only. Then in that case, option 4 is true, and thereby there will be only one option that is not true, that is option 3. Therefore, the answer to this question will be option 3 under this modification, under this suggested modification. The answer to this question is option 3, and I am sure that you have understood the solutions of all these 3 questions from the section Linear Algebra that have appeared from TS Set 2023 March examination. I am sure that you have understood the solutions of these problems, and if you like my videos, please like, share and subscribe, and I wish you all the best. Thank you.